In this video, we're going to look at another applied problem that results in a system of 3 linear equations and 3 variables. Once again, after we read through the problem, we have 4 basic steps. First, we're going to define the variables. We're going to be specific. Second, we're going to figure out what types of information we have and organize it in a table. We're going to set up the equations, report the augmented matrix, and use a calculator or technology to solve the system of equations. Then finally, we're going to state our solution in a complete sentence with appropriate units. Suppose a company sells 3 models of laptops, Model A, Model B, and C. Model A requires 4 hours of assembly, and its parts cost $250 per laptop. Model B requires 3 hours of assembly, and its part costs $300 per laptop. Model C requires 5 hours of assembly and its parts cost $400 per laptop. The company has 626 hours of assembly time each week and $49,750 available each week for parts for these 3 models. If they make twice as many Model B laptops as Model C laptops, how many of each model do they make each week? So our first step is to define the variables, and as I have stated in the past, one easy way to look for how to define these variables is to look at the last sentence. Often they very explicitly tell you how to define them. And if we look at our final sentence, it says, if they make twice as many Model B laptops as Model C laptops, how many of each model do they make each week? So the how many of each model, that tells us how we're supposed to define our variables. Since they're talking about A, B, and C, I'm going to let A, B, and C be my variables. Capital A is going to be the number of Model A laptops made each week. Capital B is the number of Model B laptops made each week. And capital C is the number of Model C laptops made each week. In math, it makes a difference between having lowercase variables and uppercase variables. If you have a lowercase variable and an uppercase variable, those are actually 2 separate variables. So don't go back and forth between capital and lowercase letters in the same problem. Now we need to organize the information that we have, and what I like to do is always put my different variables in the different columns, and then I usually have a total column. Looking back through the problem, they give me lots of numbers about assembly time, and so I'm going to have one row in my table all about assembly. Each Model A requires 4 hours of assembly time, Model B requires 3 hours, Model C requires 5 hours, and I have a total of 626 hours. For Model A, each Model A requires 4 hours, so my total number of hours assembling Model A laptops is going to be 4A. The total number of hours assembling Model B laptops is going to be 3B. I'm going to have 5C for my time for Model C laptops. This is going to total to 626 hours. So if I add these things on the left hand side here, it should total to 626 hours. Can you find the corresponding equation about parts cost on your own? Our parts equation should look like 250A plus 300B plus 400C equals $49,750. Now we have 3 different variables, A, B, and C. So in order to be able to have a unique solution, there's might be a third equation. I would need 3 equations in order to come up with just one solution. Otherwise, I might have many different possible solutions. If I read back through my description of my problem, you'll notice that I have this other statement here that tells us if they make twice as many Model B laptops as Model C laptops, that gives us a relationship between our Model B laptops and Model C laptops. If we think about that relationship, when we see this word twice, many of you are probably thinking, oh, hey, I'm going to multiply by 2. But the question is, do I multiply 2 times B, or do I have B equals 2 times C? We have to figure out which equation is correct. If you think about our Model B laptops, it says we have twice as many Model B laptops as Model C laptops. Our Model B there's twice as many of those Model B laptops, so this should be a larger number. Model C laptops, this should be the smaller number. So if you multiply by 2, are you going to multiply the larger number by 2 or the smaller number by 2 in order to make them equal? Another way to think about this is, here's a relationship that has that twice as many relationship. These are not the correct numbers. But suppose one of my numbers is 100 and one of my numbers is 50. In order to make these equal, we can't multiply the 100 by 2. We have to multiply the smaller number by 2 in order to make them equal. We've already determined that our Model B laptops, this is my larger number, and the Model C laptops, this is my smaller number. I have to multiply that smaller number by 2 in order to make these equal. So this is the correct equation, and this equation here would be incorrect. Now remember, we're going to need to put this in an augmented matrix, and so we need to write this so that all my variables are on the left side of my equation, and I just have a number on the right side, just like I have in these first two equations. If I were going to move this 2c over to the other side of my equation so that I have my variables both on my left and nothing else but maybe a number on the right, it would look like b minus 2c equals 0. Our third equation is not going to be written like this, it's going to be written like this, because this is how we need it in this form in order to write our augmented matrix. Here's our system of equations. Now we're going to put this system of equations into this augmented matrix. Here is my augmented matrix. When I put all my numbers in, I would input this matrix into my calculator and then have my calculator put it into our REF form. My calculator would give me a matrix that again has 1s on the diagonal here and 0s above and below, and then these numbers in that last column give me the values of my A, B, and C. So I should get A is 63. And again, I'm looking at this row of the matrix, and that tells me A equals 63 because it tells me 1A plus 0B plus 0C equals 63, so that gives me this A equals 63. I get B is 68 and C is 34. Notice the relationship between my B and my C. I have more Model B laptops than Model C laptops, and in fact I have twice as many Model B laptops as Model C laptops. The last thing we need to do is state our solution in a complete sentence with appropriate units. Our sentence should look something like, the company should produce 63 Model A laptops, 68 Model B laptops, and 34 Model C laptops. That's it for this video. Hopefully it was helpful.